Hello and welcome back. In this lecture I want to talk about accessing the value that a pointer is pointing to. So remember, pointers, they store memory addresses. That memory address actually contains a value of somewhere. And so pointers point to that memory address. I want to get the value of what it's pointing to. Because if I were to just print out the value of a pointer, that would be an address. But I want to get the address, I want to get the value of the address. So you can access the value of an address that a pointer is pointing to using the indirection operator. The indirection operator is the asterisk. So we learned how to use the asterisk to declare a pointer. We're also going to use the asterisk to find the value that a pointer is pointing to. So it's also referred to as the dereference operator because you use it to dereference a pointer. So for example, if you have a number it's equal to 15, you declare a pointer of type int pointing to an int, and you assign it the address of number using the ampersand. Now how do you get the value of what pointer is pointing to? Right? You can dereference it. You can basically, what the value that the pointer is pointing to is the value is 15, right? Because it's pointing to the address of number, which is 15. So the pointer variable contains the address of the variable number. You can use this in an expression to calculate a new value for the result. So say we wanted to do result equals the value that the pointer is pointing to plus 5. You would use the asterisk for it, right before the name of the pointer. And so what this would do is it would basically say, what is pointer variable pointing to? It's pointing to 15, add 5 to it. It's the address that the pointer is pointing to. What is the value of that address? So the indirection operator, asterisk, you should have noticed, is also the symbol that's used for multiplication, and it's also used when you declare pointer types, right? So this can get very confusing. How do you know necessarily what's going on, or how does the compiler work? Well, it's all about context. It depends on when you use that asterisk and where you use it. If you use the asterisk when you declare a pointer, right after the type of the pointer, then it's obviously using a declaration. If you use the asterisk in between two numbers, then it's being used for multiplication. And if it's used right before the pointer name on the right hand side, for example, or the left hand side, it's going to be assigning a value or accessing a value. So it's all about context when you use this indirection operator. Okay, and that's how it works. So that's how the compiler is going to interpret it. Whenever you see it in this example, star pointer, and you don't have a data type before it, or you don't have two numbers on each side, then you know it's an indirection pointer, a dereferencing. So let's go through an example. Here's another example where we're going to create an integer count equal to 10. We're also going to create an integer of type named x, another variable. We're initializing count to 10. X is initialized to nothing. We then create an int pointer. We know it's an int pointer because we have the asterisk after the data type. And then we named it int pointer. We're now going to assign to that int pointer the address of count. Because remember, pointers only contain addresses as their values. But they also are pointing to something. So we can then assign the variable x whatever int pointer is pointing to. What is the value of the address that is contained in int pointer? So x is going to actually display 10. So if we go ahead and display that, saying count percent %d IRD, x percent IRD, count is equal to 10, x is going to equal to 10. That's how you can dereference a pointer and get the value that it's pointing to. If you want to display the pointer's values, because remember, a pointer has a value in memory. It's just an address. So what if you want to display the pointer's value, which represented by a hexadecimal number, an integer, or an address? Well, you can use the format specifier of %p. We talked about this before. This will output a pointer value as a memory address in hexadecimal form. So if we were to do something like this, where we declare our number, we declare our pointer, we initialize it to null, because that's good practice. We want to always do that. Whenever you're not assigning something in a declaration to the pointer, make sure you initialize it to null. We then assign our number variable 10, and then we assign our pointer to the address of number. So the value of p number is actually going to be an address. So if we were to try to print it out, we would use %p, and that would be the value of the address. If we wanted to print out what it's pointing to, we'd have to dereference it using the indirection operator. But when you print out the address, what it does is it prints it out in hexadecimal. And pointers occupy 8 bytes in memory, and addresses have 16 hexadecimal digits. So how does that work? Well, it depends on whether or not your machine supports 64-bit or 32-bit addresses. If your machine has 64-bit operating system, then you're going to see 16 hexadecimal digits. If your machine or your OS only has 32-bit addressing, then you'll see the hexadecimal represented as 8 hexadecimal digits. Now, what if you want to display an address? Right? And you may say, well, what's the difference? Because the pointer has a value, right? But you can also display the address with the address of operator. So in this example, we want to display the address of number. Number is not a pointer, right? Number is just an integer. If we want to get the address of that, we use the ampersand. If we want to display the address of that, you just use %p again. You just apply the ampersand. Right? So if we supplied the ampersand with the pointer variable, we would actually display the address of that pointer, not the value of the pointer. Remember, the address of the pointer is some address in memory. The pointer value is an address that it's pointing to, and the value that it's pointing to is somewhere else in memory. So remember that illustration where we showed how pointers work. A pointer, when you declare it, it creates memory for that pointer, 8 bytes. The value of that pointer is an address. And then whatever that pointer is pointing to is a value, usually of the type that you provided. But remember that there's really 3 parts of it. If you want to print out the P number's address, you again would use the ampersand. That would be the address of the actual pointer. And you would have to use the void star to get around a warning. So remember, a pointer itself has an address, just like any other variable. It gets allocated when you declare it. You use %p as the conversion specifier to display addresses. You use the ampersand, the address of operator, to reference the address that the P number variable occupies. Right? That's the address of the pointer. And then again, the pointer has a value of an address. The cast avoid is to prevent a warning from the compiler. Specifically, the %p specification expects the value to be some kind of pointer type, but the type of ampersand number is a pointer to a pointer of int. And so you have to cast it. Displaying the number of bytes a pointer is using. Another way to get information about a pointer. Here you can use the size of operator. We've learned about the size of operator to display different data types, bytes. You can do the same thing with a pointer. On a machine that I'm running, this will occupy 8 bytes, and the machine address has 64 bits because it's a 64-bit operating system. And you may get a compiler warning when using size of this way. Size t is an implementation defined integer type. To prevent the warning, you could cast the argument to a type int like this. So what you would do is you would say p number size %d bytes, and you would say int, cast it to an int, size of p number. That's going to give you the size of the pointer in memory. Size of pointer of that address, which again is 8 bytes on most systems, because that's just containing an address. Another example here, this is going to display a number of things, and we'll run this example to show the output. But just before we run it, I want to describe a little what's going on here. We have a number that's declared. We have a pointer that's initialized to null. We set the value of number to 10. And then what we want to do is we want to print out the address of the integer number, and we want to print out the value of number. Very simple. Using the address of operator and then just the variable. When we do the address of operator, we do %p. We're then going to assign the address of number to our pointer. We're then going to print out some pointer information. We want to output the address of the pointer itself. We can just use %p, void star, ampersand number. We want to see how many bytes that pointer has in memory. We can say size of. We want to see the actual value of the pointer, which is an address. We can just say p number without any kind of extra information. And then we use %p. If we want to see the value that the pointer is pointing to, the value at the address, then we do star p number. We use the indirection operator. And we know that p number is pointing to an int, so we can say %d. So let's take a look at this example in code blocks to see how it's actually displayed. What we're going to see is some hexadecimal numbers for addresses whenever we display addresses, and we're going to see values in other cases. Okay, so this should look familiar. This is just a program that is showing you how to access different parts of a pointer. So again, we have a regular number data type int, and we have our pointer. We initialize it to null. We're first going to display our number, which is 10. So this is going to display the address of number. And then it's going to display the value of number on lines 10 and 11. We're then going to assign our pointer the address of number. If we want to see the actual address of our pointer, we just use the ampersand, the address of operator, and we cast it to a void star. We use %p. If we want to see how many bytes the pointer is in memory, we do %d, size of. If we want to see the address, the value of of the pointer, we do %p and we just say p number, because p number is an address. If we want to see what the pointer is pointing to, what the value of the address that's in the value of pointer, we just say asterisk p number. We dereference it, the indirection operator. So let's run this. When I run this, hopefully we can see both. You'll see the first two things that are printed out, the numbers address, which is on line 6, and that's some hexadecimal number, 0060FF0C. Right? And this is actually running a 32-bit program, so you see it's only 8 bits. We then print the value of the number variable, this is 10. We then print out the address of the actual pointer to allocate in memory. It's a different address than number, because this is the address allocated for the pointer. The pointer number size is 4 bytes, and that means it's a 32-bit addressing. The pointer's value, which is the address of number, it should be the same, and it is 0060FF0C. Right? And you see that you can actually get the number address by just using the name of the pointer with %p. All right, and we saw size of operator 4 bytes. If you want to get the value that p number is pointing to, which is 10, you have to dereference it using the indirection operator, and you see that it's printed 10. But you see you use %p whenever you're displaying addresses. You use the %d when you're displaying values of the integer pointer or the number of bytes. So this is the basic syntax of accessing pointer values. Address of pointer, ampersand, value that the pointer is pointing to, just the name of the variable. And well, so the value of the pointer itself is just the name of the variable. Then the value that the pointer is pointing to, use the indirection operator. Thank you. Hope this helps. Study this, run this through.